In question 5, we're given these terms and we're asked to show that the sequence is quadratic. So the difference between 12 and 16 is 4, 16 and 23 is 7, 23 and 33 is 10, and 33 to 46 is 13. So that's the first difference. Second difference, 3, 3, 3. So we can say that the sequence is quadratic because the second difference is the same, and 2a is always equal to the second difference. So a is equal to 1.5. And I'm going to show you the way I want you finding these quadratic sequences now. I'm going to write the sequence out again. We're going to go back to term 0, which is always c, if you imagine where it crosses the y-axis. And then we have another little trick to get b. So 4, 7, 10, 13. So we imagine going backwards here to t0. What would it be? Well, going back this way, we're taking away 3 each time. So this number has to be 1. 16 minus 4 is 12. 12 minus 1 is 11. So c is equal to 11. This is a great way to do them. And always, if I write my sequence out, an squared plus bn plus c. If n is equal to 1, if we put 1 in for n, we're just going to get a plus b plus c if we put t1. So a plus b plus c is always equal to t1, which is 12 here. We have a from up above, 1.5. We just got c to be 11. That's 12.5. So b, we're going to have to take away a half. It looks like here, 12.5 plus b is equal to 12. So b is equal to minus 0.5. So we have our sequence. Tn becomes 1.5 n squared minus 0.5 n plus 11. So we have a, b, and c, and then find t30. Just put 30 in for n. I will check this sequence actually now first. Let's just check t3, random 123. We should get t3 to be 23. 1.5 by 3 squared will be 9, minus 0.5 by 3 plus 11. So 13.5 minus 1.5 plus 11 is going to give 24.5 minus 1.5, which is the 23 that we circled there. So we are correct. Always check if you can with maths. So let's just go down and get t30. You use a calculator. 30 squared is 900 minus 0.5 by 30 plus 11. That's going to be 1350 minus 15 plus 11 is 1350 minus 4, which is 1346 is t30 for this question. Question 6, we're given, well, we're told the first 4 terms. It's not like there's any mistakes in this book. We're only given 3 of them. So what's happening here? Well, this one block here seems to be consistent. So what's happening with this here? This is just one block plus one block. I'll come back to this in a minute. Then we have one block plus 1, 2, 3, 4. And then at the back there's 4 as well. So there's 8 there. So it looks like a square here. It's going to be 2 squared at the front. And we're going to have 2 of them, 2 rows of it. And then the third one is 1 plus, at the front here we have 9, which is 3 squared, and you can imagine there's 3 rows of it, so it's going to be 3 squared at the front times 3. This looks like it's cubic, so 1 plus 2 cubed. This is 1 plus 3 cubed, and this is going to be a 1 by 1 in here. I've left it blank. 1 plus 1 cubed. So this is definitely a cubic sequence. We'll look at the questions in a minute. So it looks like 1 plus n cubed is our pattern. We normally write this as n cubed plus 1. Tn is equal to n cubed plus 1. So try and identify what's happening in the sequence. Makes it a little bit easier. And now let's look at the questions that follow. So how many cubic bricks in the first 6 terms? I'm going to just write down n cubed here. This is how they build up these questions. N cubed is 1 cubed is 1. 2 cubed is 8. 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. 6 by 6 by 6 is 216. And if we add 1, we're going to get 2, 9, 28, as the dog has a bad dream, 65. He's dreaming about cubic sequences. 126 and 217 is my sequence here. Put some commas in. And the sequence is cubic. And then they're bringing in a less than here. How many of them are less than a million? Well, n cubed plus 1 has to be less than a million. So n cubed will have to be less than 999. 999. So n will have to be less than. And we would write it the cube root of 999. 999. So n is going to be less than 99.99. I'm sure you could see the answer is pretty obvious doing it a different way. So the 99th term will have less than a million. The 100th term is going to be 100 cubed plus 1, which would be 1,000,001. 1,000,001. So that won't work for us. So it's definitely the first 99 terms will be less than a million.